Hello, Unite. This is my tutorial on how to use Sims Scale, which is the way we can work out how aerodynamically efficient our shape is. I've decided I want to see what happens, how aerodynamic our shape would be if we just uh, were to put wheels on it and put it and like launch it without cutting any of the sides off. So I've got the base block here. I've put 4 wheels on the shape and I'm going to see how it goes. So to simulate it, we are going to be taking it out of Fusion. And the way we're going to do that is there's this menu on the side, which is all of the different things that you have in your drawing. Bodies is the object. And I'm going to find body 1, which is everything I have, including the wheels. And I'm going to right click on that and then find Save as Mesh here. Save as Mesh will export it. I'm going to choose STL binary for our format. I have it written up in millimeters, so I'm going to make sure millimeters is what I've got chosen, and then I'm going to go OK, and it's going to bring up this menu, and I'm going to call it a name, so I'm going to go CO2 car, and I'm going to be saving it somewhere on my computer. So, and save that, and then I'm going to come over to this website SimScale, which I'll have linked somewhere for you. Okay. When you first make an account, we can go through that together. You're going to come in and you're going to see this, and you'll have sort of a blank thing where my projects are. And you're going to create a new project. I'm going to call it CO2 car block, like this. Okay. On a free account, you can't make it private, and I believe you have to create a description. So I'm just going to copy my title and put it in again. And then category, I'm going to go with other because it's educational and it doesn't fit into any of the other categories. And then go create. I don't think anyone's going to come find your design and steal it, so I wouldn't worry too much about that. But it's going to load up this file and it's going to ask you to import the file. Okay. You can import it from other CAD programs, but from Fusion we can't, unfortunately. So we're going to import and we're going to find where we just saved our file and then open and then import. And it's going to take a little bit to import. All right, happens pretty quickly. And it works it all out. And you can get your block here, like so. Here is my car. Now, there's a bunch of different things we need to do to set up our test. And we're going to go through those. So the first thing I've realized is I've actually designed the whole thing sideways. It doesn't really matter, but it's just something to know that you got to import. If you CAD things in the right orientation, it'll import in the right orientation. I obviously didn't, and it'll just look a bit strange. So what we're going to do is we're going to add a flow volume. This is where the air will be flowing. It's where it's going to calculate all the air. And we're going to go external. So this will be bigger than the shape we make. Okay. Now, we're going to zoom out so we can see it. Right now, it's absolutely massive. And we're going to have to adjust these values so that it's approximately the right size. So the first thing I'm seeing is I want the wheels to sit on the floor. So I'm going to make my Y minimum, which is Y is up and down. And my minimum is going to be the bottom of the box. I'm going to make this much higher. So I'm going to go with what, 2. 2's too low. Let's try 10. 10's too low. What about -10? Okay, -8. I want the wheels to be nice and just sitting there, not too high off the ground. If I can get them to just touch, that would be perfect. 9? No, 6. Okay, I think I'm going to be happy with that for now. Maybe 6.5. And then having it nice and big above is great. You want to have it too close to the top because in real life there's a lot of air above it. So you want to kind of get that. And you want to have a decent amount in front and behind. So for our Z, we might go, that's probably big enough. We might go a little bit bigger. -500, +500. And then 500, -500, +600, right? And then we're going to hit apply. Okay, and that's going to create this volume. Now, your object is kind of hidden inside it. The easiest way to see it is if we change how it renders so we can see stuff inside. It's called translucent. With surfaces, you can see the shape inside it. What we want to do now is we're going to use our CAD to delete a little bit of the flow volume. So how we're going to do that is we're going to come here and find Boolean, and then we're going to go subtract. Okay, the target is the big thing, and then the tool is the small thing that you're cutting off it. So like that. Okay, you can choose to keep. I'm going to discard it. I find it gives less error messages later. This thing will spit a lot of error messages. So we do that, let it load, have a think, and we get this. And now you can see it's all the same piece. Okay, once you have that, and you've only got one object, we're going to go create simulation. I'm going to pick incompressible. This is for when your air is going slower than 100 meters per second, which our cars will be doing. So incompressible. Okay, now we're in our incompressible study, and we've got to set a whole bunch of different factors that it's going to think about. The first thing is the material, which is the material you're traveling through. This is air for us, and we're going to apply. And then boundary conditions is what does it think about all the different surfaces? So the first most important one is velocity inlet. This is the air flowing in front of it. Okay, and we're going to pick the face in front of the car. Okay, and then you're going to look down here in the corner. There is a way of knowing which direction is which, and you'll see X is the direction that sort of goes along the car. So we're going to get our X value, and we're going to set that to 10. That's approximately how fast our cars will be going, 10 meters per second. It's about 15, 16 kilometers per hour from memory. And then we're going to hit OK. And you've got our first one set. And then what we're going to do is we're going to add another boundary condition. And this is going to be an outlet. So this is where the air can leave from. I'm going to say it's going to leave out the back. Okay, we're not going to change this. We're going to say it can leave at any pressure above 0. So as long as it's got positive pressure, it will exit, like so. Now, the next things we need to set are the walls. Walls are important. They will just sort of define everything else. And we're going to pick our walls to be the 3 top surfaces, the ones far away from the car. Okay, and we're doing wall function is this means it's less, they're going to put less work into calculating next to these walls, the air next to the walls, and we can save that. Okay, once you've got those ones sort of worked out, we can click on our parts, and then if you right click, and you can hide them. Okay, right click, hide, like so. Right click, hide, and you can do the front and the back too. Okay, this will just make it easier to see car later on. The ground I'm going to keep. I think the ground's important to see. And now that I've got all of that, I'm actually going to go back to the regular viewing mode like this. So I can see the car, I can see the floor. What is important to do now is we're going to set a couple more things. One more we're going to set is another wall, but it's going to be this bottom wall. And we're going to change it from wall function to full resolution. And it means it's going to think a lot more about the air that's right next to the floor. Because our car is quite close to the floor, this is quite important to us. And then we can hit OK. Okay, so this is saying this is the 6th run I've done. I've had a few practice runs to get this right. You'll see it's going to say how long it thinks it's going to take to work out. And it's actually quite a while. So when we're going to be doing this, I recommend doing it near the end of the lesson so that you don't have to sit around for what could be half an hour waiting for this to do it. Okay, so this is going to compute. I might cut bits out just so that you don't have to sit here watching me watch my computer. I guess I could tell some jokes. Okay, I just paused and stopped it halfway through because I realized I've forgotten a really important step. This is an important step for having sort of results that make sense. Okay, what we're going to do is we're going to come into this results control section, and we're going to go forces and moments, and we're going to go forces and moments coefficients. Okay, so this will tell us, you know what, we can go both. We're going to pick both for now. And we're going to select the faces that we care about. So this is not the floor. This is all of the other faces of our car. Okay. And the bottom of the car is very important too. If you're struggling to see things, what we can do is we might just hide the floor, and then it should be a little bit easier. Whoops, sorry, zooming the wrong way. A little bit easier to see all the things that you've missed. Now, I think I've got them all now. Okay, and then we can go okay, and it will load that up. And then we'll also, okay, and now I'm going to do coefficients, and I'm going to select all the same things. Okay, happy with that? And I can go okay. All right, with those, it will give us numerical information on what we're supposed to be doing. And then we can come back in and we can run it again. And we're just going to wait for that to run. Okay. Sorry. I had to talk to someone. There might be a bit of a weird cut there. Okay, so we're now in the results viewing section. There's sort of two different types of results we can look at. The first type are these very colorful graphs that look really pretty, and they can kind of show you which parts of your car are doing well and which parts are doing poorly. And then the second thing we can look at is more of a numerical value, which will say the overall how good your car is or how bad your car is. So you can do a bit of a scientific study with that sort of thing. So there's quite a few different ways to view the results. I think the one that looks the best and a lot of people will like to do is what's called a particle trace. So we're going to go add particle trace up here in the corner. Okay. And then we need to say where the particles are coming from. So they're going to be coming off this wall here somewhere. So we're going to pick a position. Ooh, what happened? Sorry, I just accidentally turned something off. Before we do that, sorry, I'm actually going to hide some of these surfaces we had before, just to keep it easy to see. So you select them and then hide selection. Select, hide selection. Select, select, hide selection. Yes. Okay. Particle trace. The position is where it's going to spawn the particles from. You want to go in front of the car, about there. Like there. Like there. Yes. Amazing. Okay. I might want to drop that down a little bit lower to maybe there. There. Yes, there we go. Maybe one little step lower. I want to have some of these dots at the bottom kind of on the ground. I think it's very important to have that. The other way we can do it is we can just up our spacing a little bit. So it's like there. Right? Now they're pretty much on the ground. The other things we can have is how many. So right now this is a 10 by 10 grid. So there'll be 100 particles moving across. And then velocity is magnitude. Is they're going to be colored based off how quickly they're traveling. And I like comets. I think comets are the easiest to see. So then the next thing we're going to add is what's an animation. I'm going to add that to the thing. I'm going to go animation type and we're going to go particle trace. Okay. And then when you play this and let it load for a bit. No. Pause. Particle trace. Trace from both directions, comets. Did I put the air in backwards? Have I set this up on the wrong side? I may have done. That would be super awkward. Yes, I have set it on backwards. Oh, no, I haven't. Wait. Uh, animate. Play. Which way are they going? Oh, okay. Yeah. I clicked on the wrong side. If it goes wrong, click on the other side, is what I've just learned. So I've also selected a position. You can see how this is how the air is flowing next to the vehicle, and it's not really changing at all. So we're just going to re-pick our position, and we're going to pick somewhere a little bit more appropriate, maybe there. And then when that loads up, we can play our animation again, and you can see the air now coming over our vehicle, right? You can see it slowing down when it hits into the front, and you can see it slowing down behind it as well. There's lots of air behind it. It's very slow, these ones along here. So this is a good way you can sort of visualize what's slowing down the car. You can see down our front slowing it down and our back slowing it down. The other thing we can do is we can do what's called the part coloring. So right now it says a solid color, but if we look at pressure, you can see there's a lot of pressure in front of it, and then there's some pressure behind it, right? And you can see how the car really affects air quite far away from itself, all the way out to here on both sides. And you can see the different colorings we're getting. So between a combination of these things, I think it's really clear to see how this flat surface at the front is pushing the air in a really weird way at the front, and then our big flat surface at the back is really sucking it backwards as well, with it not being very good behind here. Now, what's interesting is the wheels. You can't really see from either of our graphs how the wheels are acting. So that might be something we need to look at it in a different perspective. So I'm just going to pause the animation so that it doesn't look like that. And what we're going to do is we're going to look at a cut plane. So this is where we can look at the different factors over a wider area. So I'm going to turn the plane on. Now my plane is currently vertical. I'm going to swap that to Z to be going along the vehicle. Okay, and you can really see also with our car is having quite a big impact on pressure above the car as well. Right, we've got pressure here going right up above. The yellow is the normal color, and then there's variations from the car really, really high, and we've got stuff happening really far behind too. So what I'm going to do is I can move the position of the plane and I'm going to try to get it so it's sort of on the edge of these wheels just here. It's a little annoying to move. I'll go over a little bit further. Okay, right. So this is now really on the wheels. And you can see our front wheel here is having massive impacts on the air around it. The car is, but then this wheel, you can really see right up behind the wheel, there's a lot of stuff happening that wasn't happening in other locations. Now the back wheel has a bit of pressure underneath it at the back, but not really too much because it's in line with that front wheel. So that's sort of how we can use the different coloring features. You can play around and have a look at other ones. However, the other thing to look at is our force plot. No, not our force plot. Our moment plot. Solver log. No way. Force coefficients. Here we go. And there it is. Okay, so this is how much drag we have coming out of the car. So you can see our car is producing about 14, as a number of about 14. Okay, so the closer to zero, the better your vehicle is. And you can see it's really varying. It goes up and down a lot, just kind of cycles around a bit. And we want to get this number as low as possible, as small as possible. So negative 14 is quite really, really bad. To put that into perspective, I did a car before, which I put a little bit of effort into shaping, not a huge amount of effort. I didn't do anything crazy with it. I'll see if I can open that one up. It's this one. This is what I'm sure our race cars will be looking like. And we can see the amount of drag we got here. When I come to simulation runs, I believe it was run 3 and force plot, and we can look at the graph here. We can see that mine was 0.6 drag coefficient, whereas in our most recent one, we were 14. So there's a massive, massive difference. Anyway, thanks for listening to my TED Talk.